I am Jeff Treese, and the surname Treese comes from a German immigrant, 1733, Andreas Dries, D-R-I-E-S or D-R-I-E-S-S. Today, in the United States anyway, if you find someone whose name is like that, whether it's T-R-E-A-S or T-R-E-A-S-E or even D-R-E-E-S-E, the chances are really good that they trace back to that immigrant. I've been doing genetic genealogy for a number of years. I also have a technical background, being most recently employed at IBM. I'm retired now. I have a lot of experience with databases, and a lot of times that comes in as an advantage when doing genetic genealogy. I'm going to talk today about match lists, and I would venture to say that pretty much anyone who's doing genetic genealogy, who's working with DNA matches, is working with match lists, even if that's just a piece of paper that you're writing names down on. So this is in some ways very basic discussion, but it's one that I haven't seen very many treatises of. So basic doesn't necessarily mean simple. And I'll be talking, for example, about ancestry DNA, where I'll just say it, you have to jump through a couple hoops to get a good match list from ancestry DNA. So I'm going to talk about the different testing companies, what's in a match list, and then how to manipulate that. And I've got an example, a couple of examples really, of using data from the match list for other things. So I hope that I want to thank everyone for taking a little time out on Saturday to join this. I know everyone's time is valuable. I do hope that everyone on this call gets something out of this, and it should be pretty quick, and there should be time at the end for questions. You'll see on here a link to the slide deck. If that link doesn't work for you, feel free to put that in the chat box and I'll give you a different link. But this is going to be on a bunch of the slides, so you don't have to copy it down right now. Good. If you think you're pretty good at time slicing and you want to try some stuff out and you think you can still listen while I'm talking, then it might be able to come up with some better questions and get the collective wisdom of the people on this call to get those questions answered. I'm going to talk about what's in a match list, kind of at the minimum level, and then what you'll find in different versions of match lists from different places. And then how do you get that match list? And in some places, it's very simple. It's very intuitive. You click on a button and it gives you a CSV file. Most people know what to do with a CSV file, but I'll go into that a little bit. Set up in tools that I use, and this is not for me to tell you, what you should use, but just to make you aware of how I arrived at my results and why I use the particular tools that I do. And that includes the operating system, and includes the office productivity and spreadsheets and the total environment. And then kind of in the hands-on part, I'll show getting an ancestry DNA match list, which is kind of the trickiest one as far as I'm concerned to get. Some software that I developed for helping you with that task. Then I will show an example of using Gephi, which is a graph visualization, a node graph. Wrap up with hopefully some good questions and answers. So what's in a match list? In my opinion, the match list needs to contain at least some unique identifier for the person that you're matching. Remember, we're talking about someone who's sharing DNA with you when you get your test result back, and you have someone who shares a DNA segment with you or multiple DNA segments. So there should be a unique identifier so you know who you're talking about. And then you should have the amount of shared DNA in centimorgans. To me, that's the basic requirement if you're going to do anything significant with a match list. But as most of you probably know, match lists often contain other things. They may contain segment data, the chromosome, the starting and ending position, may contain the number of SNPs compared. You might have contact information, email address, the haplogroup information, both for the Y-DNA and the mitochondrial DNA, number of segments. So when you get some of the more complicated match lists that you might download from a testing company, you're going to find some stuff in there that might be a little overwhelming if you make it so. Mostly what we're talking about is comma-separated value files, which is a text file that you can open in any text editor and can manipulate it that way. You can also open it with probably any spreadsheet program that you have access to. It's called comma-separated value because commas typically separate the data that are in the different columns in the spreadsheet. But it doesn't have to be a comma. It could be some other character than a comma. Okay, so what are some of the uses? Well, if you're contacting your DNA matches, which is really the way to progress your family tree, then you need notes and contact information, and you need some way of organizing it. So that stems from a match list. The chromosome maps all relate back to the match list, who has that shared chromosome section with you, and generating input for node graphs, maybe even the one that we just listened to. Figuring out cluster groups who are related via the same shared DNA, finding matches in common. So basically the bottom line is that matched lists really drive a lot of your activity that you're doing day to day. Unfortunately, how you get the matched list varies. With Ancestry DNA, you're really on your own. With some third-party tools, I'll talk about mine being one of several different ones that you can use today to get that match list. Family Tree DNA makes it easy. There's just a button. You go to your Family Finder matches and you download that file. MyHeritage, similarly, you do click on a button, but then you wait to be notified that that's ready. It's sent to you in mail. 23andMe, it's relatively easy. You request the match list and then they notify you it's ready. And gedmatch, there's several methods, and I know Tim is a big gedmatch user, so he may have some more to kick in with people have questions about gedmatch. But there are a few ways, and I'll kind of mention those. I'll mention what I use. As I said, I'll talk about my work setup a little bit. Basically, when I'm working with match lists, I'm always using a spreadsheet. And what I use for that is the LibreOffice Calc. LibreOffice is free and open source office productivity suite. So it's available on the platform you're using and not tied to a particular OS or subscription or anything like that. Sometimes I use a text editor. Hopefully everyone is familiar with some text editor. That could be Notepad, could be Emacs, VI, Vim, the list goes on and on there. But it's something that allows you to open and save a text file. And then more rarely a Python program. Here's just a screenshot of match list in a spreadsheet. I also use Linux. I think a lot of people these days assume that you're using Windows, and I know a lot of people are on Mac, a lot of people are on Windows, a lot of people are on Linux. I use Linux. If you find any limitations with the operating system you're on, this is a free operating system that you can get from a number of different places. I gave an example here. You can run it temporarily, or you can permanently install it to run really any software you want to run. That's what I use. Again, I'm not telling you that you should use any of these, but I'm just painting a picture of my environment. I use LibreOffice, I already mentioned that. I don't want to impose, since I'm a co-administrator of 6 different group projects at Family Tree DNA, and do a lot of stuff for the public sphere. I donate programs and I help people with their problems and all that stuff. I don't want to impose new requirements on people. So basically, I'm going to insist that for myself, that the stuff I do is available and accessible by everyone. And that means not a proprietary operating system, not a proprietary particular platform. Spreadsheets. I also use Gramps as a genealogy program. And I know that GED files allow you to transfer family trees from one place to another, and Gramps can read that. But I'm trying to avoid having to buy licenses. I'm trying to avoid having to do upgrades that are only available through the proprietary vendor of that genealogy software. So I started out early with Gramps, and I find it's a little hard. It was a little bit hard at the time to switch from what I had been using before to using something new. But once I did figure that out, I'm really sold on this as a genealogy program. It does everything that I need to do. Okay, back to and then Gephi, which I said I'll mention. I'll go through an example of Gephi. Someone just asked if the slides are available. These slides are what you'll find if you go to the URL that you find on many of these pages. So you don't have to make me go back to a previous slide. I put the link on pretty much all the slides. Using match lists from Ancestry, I mentioned, is pretty tricky. So what you get when you go to Ancestry is incrementally loaded page of your matches. Anyone who's on Ancestry knows this. And it's rendered in HTML, which is what the web browser takes and displays to you. That's what HTML is. That's kind of useless as a match list. HTML is kind of useless as a match list. It's useful only to a web browser that renders it into something that you can look at. So the trick is to get HTML over into a CSV file. I ran into one of the problems that I mentioned earlier when I started looking for ways to do this, because there are some other solutions to this. I found one that uses a spreadsheet, and it sounded perfect. All you do is save your HTML file and paste it into the spreadsheet. Well, it didn't work because I don't have a license for Excel, and it required Excel with the proprietary extension language. And I started to modify that program to run in an open source way, and decided that that was not a good use of my time. So I just decided to create my own program to translate this HTML into a CSV. That's what we're talking about doing. So you get your match list, and since it's incrementally loaded, you got to keep hitting page down forever and ever. Well, I actually put a Coke bottle on the page down key, walk away, and come back later after the list is loaded. I'll say that there's a limitation to this. I have almost 60,000 matches, I think, on Ancestry DNA, and I would not try to do this with all 60,000 matches. I'll talk a little bit about how you can do this incrementally, basically divide and conquer to get your entire list if that's what you want. But I come back later when it's paged all the way down to the bottom of those matches that I filtered on. And then I save that page as an HTML. And then I run this program. This is my program, sniff-ancestry. There's the URL to get it. GitHub is a source code repository where you'll find all kinds of interesting source code if you're a developer or if you just need to run that program. That's an overview of what's going on. I'm going to kind of go through this step by step. So first step, here's what the Ancestry match list looks like. You have these filters at the top. In this case, I filtered for the surname Pittman just to reduce the list down enough. It works for me if I have around maybe 6,000 matches. I'm sure I could go higher than that, but I don't want to try to do a match list more than 6,000. It's probably going to start getting painful because the files get really big. You might run the browser out of memory. You're probably just going to have to experiment with that. But you can filter different ways. If you're looking for a certain surname, you can filter this way. If you're looking for certain users, you can filter this way, birth locations. One way that's particularly useful, especially if you'd like to get your entire match list or some subset of it, is by shared DNA. You can just change the range of DNA that you shared and then look at a different range next time you generate the list. Scroll down to the end of the list, Coke bottle on the page down key, then save this page as. This is Firefox that you're seeing, actual screenshot from the Firefox browser. This is how it shows up for me. I think some web browsers have a different way of saving the page. You need the one that saves the full web page. That HTML file should be fairly large. If you've got that fairly large, depending on how many matches you saved, of course, then you've downloaded the correct file. And so that doesn't really depend on what browser you have, but you do have to figure out from this dialog, if there are multiple choices, which one saves the whole web page. I like to use the name a.html because I don't like the long string here. So I just change this to a.html and I save it in a particular folder on my computer. You'll need to know where that folder is when you run the program. Step 3 is dnamatch-tools. This is on GitHub. I'm going to stop sharing here and switch to a different screen for a second. We can talk for just a second about GitHub. Give me 1 second to get the web browser up. So DNA match tools, this is github.com, Jeff Trees DNA match tools. The file that we're going to be using on here is sniff-ancestry. You have to first get it. And the way I recommend getting it is download this zip file. This is a public repository. It has a code section. That's what we're looking at. It has an issues section where you could submit defects or problems you have. It's got a discussion, a wiki. But back to the code, what you see here is a description of the tools. I'll say that this entire source code effort came from an in-person meeting at the GFO that a number of years ago when I just kind of stayed around and talked to Dr. Jansen after the session was over and thought about some things. He was describing how he did some phasing of his autosomal and combining kits, mega kit into one. That's the user story for here as a genealogist who has tested at various companies. I want to combine all my data into a single data file that has the best coverage possible. And it just occurred to me that there's kind of a need for some of these open source little tools. They're not huge efforts, but that can be run by anyone, any place they want to run. So you can phase your raw data, you can extend the kit. There's a little information. Here's the one we're using today, sniff-ancestry. As a genealogist using DNA matches, I would like a list of matches from Ancestry DNA in a spreadsheet so I can keep better track, history, and notes. If that sounds like you, then this program may help you. Here's another one on here that may help. I pulled a bunch of DNA matches into multiple spreadsheets, and I would like to combine those spreadsheets into one file with duplicates removed so I can use the deduplicated rows as input to another program. So this just uses CSVs. They don't have to be matchless. They can be any CSV file as long as the two you're trying to merge or multiple that you're trying to merge. You run it merge a.csv, b.csv, as many CSVs as you want, and then the output file. As long as they have the same columns, this will merge them into one file with all the duplicates removed. And then the other thing I'd point out while we're here on this webpage is that scroll down to help and hints, because you're going to have to do a one-time setup, which is install Python if you don't already have it. And if you're on Windows, there's some videos here, or if you're on Linux, maybe you already know what to do, Mac OS, but that'll get Python installed for you and just, kind of look through this. These are good tutorials that I found on YouTube, so I didn't try to reinvent the wheel there. And ultimately, if you have any trouble with any of those steps, I'm always happy to help out where I can. I'm going to go back to the presentation. So that's getting the sniff-ancestry.py. The other way you could do it is you could click on this sniff-ancestry.py and copy all the lines that are in it. There are about 200 lines of source code and paste it into a new file. I really recommend just downloading the zip file and unzipping that. But anyway, you get that plain text file is fine. Okay, now we've got that. You're going to have to edit that file. And that's where the plain text editor comes in. So I'm going to also switch from those. Here's the file that we just saved from Ancestry DNA, a.html. And let me just show you what that looks like in a text file. I'll be using for this Emacs, which is a text editor, but you can use any editor you like. This is just a text file. We're going to go down here to this line. It says things you might want to change, this short section. Here's the output file name, and here's the HTML file. Lines that begin with a hash are comments, so you don't have to worry about what they say. You can leave them and they won't cause any harm. But this one, say you want it to be called B, you change this to b.html. There are a couple other examples for Windows or wherever you'd like to save it /temp. You just need to make sure that that's where you saved your Ancestry file. So doing this step that I'm doing right now, changing it to a.html, makes you a programmer, and you have my permission to add that to your resume because you've just edited a source code file. And save this out, and then next we're going to run that. I'm going to stop this and go back to the presentation, and I'll look and see if we got any burning questions when I do that. Saved it with the correct file names. That's just two files, the output CSV file and a.html, the thing that we saved from Ancestry. Next, you have to run the program. There are two ways of running it. If you've got things set up in a particular way, you can probably just run it by typing in sniff-ancestry.py. The other way you can run it is Python, and I have multiple versions of Python, so I say Python 3 sniff-ancestry.py. This might just be Python without the 3 on the end, might work for you. It depends if you have multiple versions of Python installed or not. But you'll know because if it runs, you'll see this reported. Jeff Treese's DNA, it'll say your tester's DNA matches, save CSV file wherever it was saved. Just ran the program, produced output. Then you're going to open that with a CSV file, but let me just show you that running that in a command prompt. Here, I'm going to share a terminal window, which would be your command prompt. By the way, you don't have to run this in a command prompt. There are integrated development environments where you can run programs from a graphical interface. This example I'm showing you here comes from a command prompt. So here's the file I saved. I ran this twice this morning, produced a 46 megabyte file. I ran it twice because I had a technical problem and I had to reboot my computer, and the file that I set up for this talk went away and I had to run it again. So it didn't take too long to do about 5,000, almost 6,000 matches. The file I just saved, a.html, is 46 megabytes. Here's my command running the sniff-ancestry. What it reported when it ran were these two lines, description, save CSV file. It took about 36 seconds to run. There were 5,627 matches the way that I filtered. I think I filtered on close relatives. The first two lines of the CSV file that it printed out have the column names, kit 1, name 1, kit 2, name 2, manager, shared, so on. That's the first line of the spreadsheet. That's going to be in any CSV file that has the columns named. And then the second line is the data for the first row in that spreadsheet. So you can see the ID 1 is this long string, name 1 is that string, and so on. So that's what actual data looks like in the spreadsheet. Then when you open the file that we just looked at, it's going to look like something like this in the spreadsheet. You got the ID, that's the kit 1, name 1, kit 2, name 2. If that kit is managed by someone, it shows up in this column. The number of shared centimorgans, any notes that you've saved for that match in Ancestry will show up here. And any grouping you've done with the dots, the color dots, will show up here. Then you have a URL that will take you right to that match. So that's what the output of sniff-ancestry looks like. You're going to have to manipulate this if you want to merge the Family Finder results with Ancestry, and there are some significant limitations to doing that. One of them is names are not a unique identifier. And I run into this all the time. Many matches with exactly the same name from Family Finder. This may not be too much of a problem if you're looking at certain surnames, but with other surnames, it's a big problem. And it's also a big problem if you're doing, as I'm doing, combining multiple testers into one spreadsheet. But you do have to get good at this. You're going to do these probably as a spreadsheet operation. You're going to copy this column, and you're going to copy, the shared CM column, and you're going to put that into a new spreadsheet, and then you're going to change the column names and merge it with your other spreadsheet. There is a lot of manual work in there that kind of flows from being good at using spreadsheets, in my opinion. What I just covered is specific to Ancestry. I talked most of this stuff on Family Finder. I don't have to spend time on this slide. Just remember, names are not unique. There is no solution to this problem that I know of. I find if you think back to what I would think of as the minimum requirements for a match list, Family Finder match list does not meet that minimum requirement because you can have multiple people with the same name in here. Now you can one by one go through and see if you can deduce who that is by looking at other information. but that's not sufficient when you're trying to do thousands and thousands of matches across a project, or you want to be able to reload a new list and go back to that again and all that kind of stuff. So I don't know why they do this, but they need to fix it. Gedmatch, I have two methods. One is select all of the cells that show up on the web page when you do your list on Gedmatch, and then paste that into a spreadsheet. But then you're going to have to edit the result, and you'll do that in the spreadsheet program. Frankly, this is what I do most of the time, because you can go to visualization options if you're tier 1, you can select all those people, and then go to the list feature there in the visualization options. But I find that to be slow, and maybe it doesn't scale to enough matches. This works with thousands and thousands of matches, but what the problem is you're going to get some rows at the beginning that are not data, and probably a few rows at the end that are not data, a column at the beginning that you're going to have to delete. But after you do that cleanup, then you'll have a match list that looks like this. And you can add whatever column titles you want to those columns. That's what I do for Gedmatch. Okay, so that was match lists. I mentioned briefly MyHeritage and 23andMe. These are simple. They're just kind of a one-button thing. The details vary a little bit, but I'm sure you'll be able to get those match lists. Gephi, as I mentioned, is a program that's been around for a long time. They just recently released a new version of it after, I think, years of not releasing any new version of it. Fixed some defects probably. But it's a node graph, and a node graph is, say, people, as an example, people who are connected. So it's referred to as a network graph or a node graph. The edges in Gephi terminology are the connections. So in this example, just type this in. This doesn't come from a match list, but then I'll show you how you can get this from a match list. Jeff is connected to Bill. That means Jeff, in our example, it means Jeff shares DNA with Bill. Bill is connected to Mike. These are our unique identifiers: Jeff, Bill, Mike, Fred in this example. And there's a source and a target. That's the edges file that Gephi needs. Just showing you how simple Gephi really is in terms of its input. Then in the nodes file, you can have a label associated with that person. So here's where in this case, I'm using the full name. The nodes file looks like this. So here are two CSV files I created by typing them in. And then we're going to look at what that produces in Gephi. In a real example, you would manipulate this match list. You would take the kit 1 would go here, kit 2 would go here, kit 1 would go here, name 1 would go here, combined with this other kit 2 and name 2 would kind of extend this nodes list. Then when you have these two CSV files prepared, you're ready to run Gephi. Here's a real example using Ancestry DNA output. So there's the Ancestry DNA ID, and there's that unique identifier that was in our CSV file. Same example, just using actual data. I mentioned this before, but I'll say it again. Get good at using spreadsheets. In my opinion, this is one of the tools that you're really going to be using in genealogy. You should know how to copy ranges of cells, paste them, into existing columns or into new spreadsheets. There's a thing called a pivot table that's really good at removing duplicates and other things for summarizing. I'm not going to cover these things. I could do so in a future session if someone wants me to, but today it's beyond the scope. But tools like merge CSV, sorting remote rows and removing duplicates, deleting rows, deleting columns, copying things to new tabs, even formulas which you can use. These are all spreadsheet skills that will serve you well in working with matches. So here's what this previous example looks like. In Gephi, here's a node graph. Bill connected to Fred, Bill connected to Jeff, Bill connected to Mike. Just pointing out that this is not the only node graph. Here it is in GraphViz, where if you go to webgraphviz.com and type in this text that you see here, it's just a particular format that GraphViz uses, it will produce the same graph that you see here. Okay, there's the Gephi kind of hypothetical example. Here's a real life example with a DNA tester at the beginning. And this I generated using shared segments. So I use triangulated data. It's really a match list, but it's a match list that has a triangulated groups, two people matching a third person on a particular chromosome and a particular segment. So I took that chromosome number and used that as an attribute for Gephi, which gives me an ability to color these according to chromosome. And then if we were able to zoom in on this, we'd see actual names in here of the people who are matching. This is a cluster of names out here, for example. And you can zoom in on it in Gephi and see who those people are. You can copy those and then do further analysis on them and all that sort of stuff. So this is sort of a node graph for an individual tester, a little bit different than the previous example. Gephi itself is a complicated, well, let's say it's sophisticated. I won't say it's complicated. It's sophisticated, has a lot of capabilities, and going over those is beyond the scope of today's talk, kind of sticking to bread and butter. I'm just using this as an example of kind of going beyond the match list. You want to obtain the match list wherever you have test results, and then you're probably going to do a little bit of your own development to figure out what kind of master spreadsheet or list makes the most sense for your work. And then you're going to probably populate that list based on what you're getting from these other match lists that you get from Ancestry, you get from GEDmatch, you get from Family Tree DNA, MyHeritage, 23andMe. You're going to do that by having good spreadsheet skills, in my opinion. I don't think there's a way around that. Just bringing up a CSV in a spreadsheet's easy enough, but you do need to learn how to manipulate that a little bit and just use the columns from that for your match list and for all your other work.